All right, Chapter 4, Pre-Calc B, Test Review, a lot of algebra. Start off with Pemdas. You got to do whatever's inside the parentheses first. So anything to the 0 power is 1. This, 3 to the negative 2, is just 1/9, or 1 over 3 squared. And then we know 1 can be converted to 9/9. So 9/9 plus 1/9 is 10/9. And I'm going to ignore the negative for a minute and just square it. So that'd be 100 over 81, but that's the same thing as being to the negative 1 power. So it'd be 81 over 100, which is letter C. On to number 2. Again, kind of PEMDAS, but there's nothing to do inside the parentheses, so we're going to let that exponent hit that negative 2. Negative 2 cubed is negative 8. Power to power, you multiply. And that'd be times 2 to x to the negative 3. First of all, negative 8 times negative 2 is negative 16. X to the 6 times x to the negative third, you add those exponents, so it'd be x cubed. And that would be letter D. Number 3. Because this right here is actually 3/2, I'm going to ignore that negative, which is dangerous because you might forget it. So I'm going to concentrate on 1/16 to the 3/2 first, which is just the square root of 1/16, which is 1/4. Now I got to cube that, which is 1 over 64. Now, again, I'm ignoring that negative here for a second. So if I go power to a power, I need to go 10 times 3/2. 2 goes into 10 5 times. 5 times 3 is 15. So this would be x to the 15th in the top. So my answer would be x to the 15th over 64 if there was not a negative exponent lurking, but there is. So now I need to flip it, 64 all over x to the 15th, which would be letter A. Number 4, we get into the logarithms. Remember, it says evaluate, which means find x. So we put our x in there, we go with a base, then to the exponent, then equals 81. Some of you can look at this and go, aha, that's just 4. Or some of you might want to take an extra second and say, all right, 3 times 3 times 3, that's 27, times 3 is 81, so it's 3 to the 4th. Common bases, happy places. So then the 3's disappear, x equals 4. There it is. This says solve. So the question you have to ask yourself is, does this negative 1/3 connect to the 2? And the answer is no. So you can divide by 2, divide by 2. So we get y to the negative 1/3 power equals 6. Now I want that to be the first power, so I'm going to raise that to the negative 3, and this to the negative 3. This equals 1. So I get y equals 1 over 6 cubed, which is just 1 over 216, which is letter B. This one's a classic common bases, happy places. So I got the 16 and I got the 8. I'm going to make that a 2 cubed. So I'm going to rewrite this as 1 over 2 cubed. That right there is just 2 to the 4th. So this is to the 1 minus x. So now I have a power to power, so I got to multiply the 4 by both of those things. So I get 2 to the 4 minus 4x power equals, now one thing I'm going to do is I'm going to bring this up over here. So this turns into 2 cubed, but it's negative because I had to bring it up to the 2 minus x power. Like I did over here, I'm going to multiply, after multiply, I get 2 to the negative 6 plus 3x. Common bases, happy places, so these disappear. So I know that this has to equal this. So 4 minus 4x equals negative 6 plus 3x. So I'm going to subtract 3x, subtract 3x, subtract 4, subtract 4. So these cancel. So I get negative 7x equals negative 10. Divide by negative 7, and I can see my answer is going to be 10/7, which is letter B. Okay, number 7, it does not say find the linear equation. That's when you would call this x1, y1, x2, y2, and you'd find the slope, find the y-intercept. That's not what it's asking. It's actually asking you find the exponential function, which is saying f of x equals a times b to the x. And remember what we said. We said when we make the chart, we got x is 0, y is 3. So when x is 0, this y value ends up being your a. So a is 3. So that's going to be f of x equals 3 times b to the x. How do you find out what b is? Here comes the trick. So 0, 3, then it goes to 2, 12. Now I'm going to jump down one because in order to find the progression, you need to have a linear progression. So what would I put from here to here? If you think, okay, I'm going to just try 3 times 2 would be 6. And then would that be consistent from here to here? And the answer is yes. So you have to create this to see the pattern. So 3 times 2 is 6. 6 times 2 is 12. So that's telling us what b is. So that's the multiplier. So that would be 2. Then I'd look for that answer, and that would be letter A. Number 8. This says identify the domain and the range of the function f of x equals log base 4x. Now in this problem, a lot of people get hung up on this, and the reality is once you see that this is just the equation of a logarithm, if you recall, the general truth is we can go for 1, 0 as our definite point, and it comes in like this, and it goes like that. Now, my drawing's not perfect, but it gives you the generic idea. Even if this was the natural log of x, we could go with the same drawing because they're so similar. So the domain is how far left does it go, and how far right does it go. So it gets to 0 for the domain, but it doesn't touch it because that's an asymptote. But then it goes on forever. So, and then the range, so this is your domain. Your range, it goes down to negative infinity, and it goes up to infinity. Now, obviously, it goes up slow, but it will get there eventually. So there's your domain and range. Now we just got to look for a match. And it looks like it's letter C. Number 9. So it says the cost of the bag of Skittles has increased at a rate of 0.9% each year. If the cost of a bag of Skittles is now 0.89, when will the cost be over $1? So if we remember the formula and put things where they belong, we'll be able to figure it out. So this is the rate of increase. So in here, that's going to be 1 plus, and this is 0.9%. So we got to move the decimal to the left 2 places. So that'd be 0.009 each year. So we'll just call that T. And if the cost of a bag of Skittles is now 89 cents, which is right here, when will the cost be over $1? So what we're going to do is just not worry about the word over $1 so much. We're going to find out when it will equal $1, and then we'll translate that information. So this is 1 equals 0.89, 1.009 to the t power. Now I'm going to divide this by 0.89, so that'd be gone. You cannot distribute this through. Be careful with that. 0.89, let me get a calculator. You can see that this is, I'll just write it over, well, I'll just keep going over here, 1.12 equals, I'm going to give myself some room because I can see this next step. So in order to get that exponent out from up there and into here, I got to slap a log on there and slap a log on there. So I'm going to go ahead and take the log of this, 1.12, and that's 0.049 equals, now this t comes along in the front, so I'm going to write it like this, times, and then log of 1.009, and so that's 0.00, I'll just call that 4. Now I got to divide by 0.004, divide by 0.004, so 0.049 divided by 0.004, and I get 12.25 years. So it says less than 13 years, over 13 years, 13 years. We're going to go with letter C, less than 13 years. And I just checked the answer for number 9, and it actually identifies it as letter B. So these answers, just the way the question's worded, might be a little tricky. But this is exactly when it would be over, it would be exactly $1. So it's going to be more than this. So both of these are open for interpretation, but it must be a little over 13 years that it actually happens. But yeah, I'm going to chalk this one up as a poorly worded question, and I can understand how you can get either one of those, really. Number 10, write the expression as a single logarithm. So this is what we called the marriage rule. The 2 shall become 1. Look for law 3. That 2 goes there. That 3 goes there. So I'm going to rewrite it. Log x squared plus log y cubed. Remember, addition means multiplication. Here comes the 2 becoming 1. That'd be x squared y cubed. So that would be letter A. Number 11 is very similar to number 9. Hopefully it's a little bit more straightforward, but in 1995, that'll be significant, the Georgia population, we're going to use this formula right up here, was 2,462,000 and is increasing at a rate of 5.5%. So that'd be 1 plus 0.055, and then to the t power, saying when will it be 5 million? Well, that would be over here, 5 million. What I like to do on these is just take these zeros out, just divide both sides by 1,000 essentially. Divide by 2462, so that'll be 1. Divide by 2462. So I'm going to go 5,000 divided by 2462, 2.03. So 2.03 equals, I'm going to leave myself some space here, 1.055 to the t. Why am I leaving myself some space? The only way I can get that down is to turn it into a logarithm, slap a log on that side, slap a log on that side. So log of 2.03, enter, 0.307 equals, and then I'm going to go over here, log of 1.055, 0.023. So I'm going to bring that in front, so that'd be 0.023t. And I got to divide by 0.023, divide by 0.023, 0.307 divided by 0.023, boom, 13 point whatever, 34. So t is 13.34 years. And it says when will it hit 5 million? So we got to go 13.34 years after this. So 5 years would be 2000. So then 8.3 more years would be 2008 into 2009. And the answer strictly says 2008, so we'll just steal that one. Okay, last problem from this recording. It says the half-life of a certain radioactive substance is 9 days. This is where it gets a little tricky. The half-life problems are asking you to kind of go to these, a, b to the x, and this will be my 1/2. So that's 1/2, and it's 9 days, so it's going to be x over 9, because on the 9th day, that'll turn it into a half. 5.5 grams initially, and that says how much substance will be present after 18 days. So that's this right here. We're trying to find y. If we stick in 18 here, well, 18 over 9 is 2, so that'd be 1/2 squared times 5.5. So all we need to do is multiply these two, all that together, and you get the right answer, which would be 1.73 grams approximately.